Good morning, everyone. We are Group 11, and the topic that was assigned to us is all about the radio waves. But before we proceed to our main topic, let us first define what is electromagnetism.
What is electromagnetism? Dictionaries define electromagnetism as a subdivision of physics that is concerned with the study of the interacting relationship of electric current or fields and magnetic fields. Ang electromagnetism daw po ay isang akto kung saan ang mga electrical charges po ay sinasabing magnetic. Nangyayari po iyon dahil sa mga kilos ng mga electrical charges tulad na lamang ng mga electron na nag-create po ng magnetic field. Ang mga example po ng electromagnetism sa buhay natin ay kuryente ng motor na ginagamit sa mga appliances, mga computer at smartphone, mga radyo at television sa pagpapadala ng signal, CT scan at iba pa. May tinatawag po tayong uri ng electromagnetism spectrum kung saan nandun po ang hanay ng mga electromagnetic wave na nagpapakita ng iba't ibang uri ng radiation. Nandun po ang mga radio wave, microwave, infrared, visible light, UV ray, X-ray, and gamma ray na nagtatangi ng wavelength and frequency. So ngayon, ang tatalakayin po natin ay radio wave. Ngunit bago yun, i-explain po muna kung sino si James Clerk Maxwell at ang mga kanyang theory.
So, who is James Clerk Maxwell? James Clerk Maxwell is a Scottish physicist who proposed the unified theory of electromagnetism in 1873. And then he also said the four main interactions of electromagnetic forces. But before I tackle about the four main interactions of electromagnetic forces according to Maxwell, do you guys know that before Maxwell found out the interrelationship of those three, the electric current, the magnetic field, and the light, it was once said before that those three are in different forces, or in separate forces. Well, here it is. Maxwell found out that those three are different appearances at the same phenomena. And then here it is. He proposed the unified theory of electromagnetism and said the four main interactions of those forces. So, what do we mean by inversely proportional to the square of distance between them? This is the electric field. This and this. It is inversely proportional because, as you can see, example, when it is decreasing, then this one is always increasing. That's what you call inversely proportional. If the one is decreasing, then the other one is increasing. It just simply means that if the electric field has a pair, example is the positive charge and a negative charge that attract or repel each other, then same goes with the magnetic field. So, ang electric current daw ay nagpo-produce ng magnetic field. And kapag na-produce na yung magnetic field na yun, ang direction niya or ang pupuntahan niya is where the current is. So, in simplest words, sabihin na natin na they cannot live without each other because it is said that a moving electric field produces a magnetic field and vice versa. So, meaning, when we produce a magnetic field, then the electric field will always come, and vice versa. before we continue, I have here a short story. And before I say that story, I have a quick question. Where do we mainly get our signals? Signals from our phones, signals on our television, our radio, and everything. Where do we get that? Where do we mainly get that? Diba? It's on the satellites that coming from satellite stations in our space. So here's the short story. Jaded and Lomo are best friends since elementary, and then they dreamed of traveling all over the world when they grew up. And then they grew up, and then the dream finally came true. And then one day while they are traveling, sakay sila sa car ni Jaded. And then Loma saw a smaller radio sa car ni Jaded. And then he asked Jaded if he could turn on the radio. Kasi gusto niya makinig sa station 99.1. Dahil alam niya sa mga oras na yon na ang station na yon ay nagpapatugtog ng mga music. And then, Jaded agreed. And then, Loma played the station. And then while they're traveling, ang mga dinadaanan na nila is mga puno. Para siyang kagubatan na puno ng puno. May mga matataas na puno, may mga mababang puno. And then, suddenly, the radio has a cracking sound. And then Loma complained. Bakit? Bakit nawala? And then Jaded said, baka walang signal. O baka nag-time out na yung station na pinapakinggan mo. And then nilipat ni Loma sa ibang station. Wala rin. Puro cracking sound. And then he even said, baka sira na yung radyo mo. But then, he never turned off the radio. Hanggang saan dinadaanan nila, ay wala na sa mga puno ng puno. Highway na. And then, the radio suddenly comes up again. Nagkaroon na ulit ng music yung radio. Sa tingin nyo, bakit? It is because radio waves has a low frequency, right? And where do we get signals? Sa satellite stations, di ba? And then the satellites has a radio waves. And then, di ba doon natin nakukuha ang ating mga signals? And then, nung ang way na ni Jaded and the Loma ay parang kagubatan na punong-puno ng mga puno, natatakpan ng mga puno na yon yung signal na binibigay ng satellites. That's why, yung radio na pinatutunog nila while dumadaan sila dun sa maraming mga puno is hindi gumagana. Because the satellites couldn't reach the destination of that too kasi maraming nakaharap ng mga puno. And then, Loma, can you tell us exactly what is radio waves?
Ang magnetic wave po ay nag-hit ng para gumana isang wire at nag-absorb para gumana. Gaya para po sa cellphone ay hindi po nag-absorb ang cellphone kapag ay nakapatay.
Did you guys know that Heinrich Hertz was the one who verified the existence of radio waves or pulses in the late 1880s? The 22-year-old Hertz was seriously thinking to prove a Maxwell theory of electromagnetism as part of his studies in Berlin. By continuing his quest to verify the theory of Maxwell, he witnessed an electrical spark in one of his devices, and that spark directed him to deep thoughts and questions. He put up his spark gap transmitter. As he was already experimenting to prove Maxwell's theory, he hoped that his electrical apparatus would transmit electromagnetic waves. At both ends of his spark gap transmitter, he put two hollow spheres of 30 cm diameter with 3 meter apart. These spheres acted as capacitors or a passive electronic component with two terminals and stores electrical energy in an electric field. As he was using his transmitter in front of his students, he applied high voltage alternating current electricity across the central spark gap, and then it produced electrical sparks through a process called magnetic induction. The sparks flew between spark gaps, small gaps in the circuit. He started producing them using a piece of electrical equipment called induction coil. The induction coil converted low voltage direct current electricity from a battery into a high voltage alternating current electricity. The electricity crossed a small air gap at consistent intervals as a spark. And then Hertz observed that sparks caused an aggressive pulse of electric current within the copper wires leading out to the spheres. These uncertain electric charges produced electromagnetic waves or radio pulse or radio waves. The radio waves spread out at the speed of light through the air around the wire. He then further observed that the sparks that glided across the main spark gap or transmitter typically soared across the secondary gap or the receiver. Further experiments that Hertz did show that the flickering at the main gaps produces regular electrical waves that is moving back and forth. He then believed that the circuit was vibrating, which is determined by electrical properties called inductance and capacitance. He identified a phenomenon called self-inductance was taking place in the copper wires. This phenomenon allowed him to deduce the electric vibration had an extraordinary high frequency. As Maxwell's theory had indicated, the main circuit of the transmitter would discharge electromagnetic waves with a wave ranging up to 1 meter or more. Hertz distinguished the pulses or waves with his receiver because the sparks jumped from the transmitter to the receiver even though it has a distance of 1.5 meters. The sparks were produced by onset of the electromagnetic waves from the transmitter, creating fierce electrical vibrations in the receiver. Hertz not only proved Maxwell's theory, but he also was able to generate radio waves. Well, you might ask, what is the connection of light in there at the end of this video? Well, light is also an electromagnetic wave with electric field and magnetic field. But the difference is its frequency is higher than radio waves. And also, radio waves can be converted into visible light and can produce visible light.